Hello class, welcome to 5.6, Graphing Systems of Linear Inequalities. Here we are only focusing on the application problems, and it makes perfect sense to understand that just like equations, inequalities too can occur as systems. And in word problems, we begin to understand the importance of inequalities. Therefore, we look at the first one. Christy sells her photographs at a booth at a street fair. At the start of the day, she wants to have at least 25 photos to display at her booth. Each small photo she displays costs her $4, and each large photo costs her $10. She doesn't want to spend more than $200 on photos to display. And we have 4 parts. Okay, so try to understand this. Okay. She's trying to display these photos to sell in the booth. And she has 2 types, small photos and large photos. And she doesn't want to spend more than $200. Now you could use the table, okay? I'm going to try to, draw a table here. So it looks, it's going to look very similar to the table ones that we've used before, but remember that we did not find a table that was suitable to this particular problem. So we need to build our own. So I have this small table here, and we can build our own columns. So I'm going to call this type because we have the small photo and the large photo, that's the type. Then we are, okay, we need the number of photos. And we need to know how many photos, that's what we got. We need to know the cost per photo. And this will be the total cost, the total spending. Okay, so type 1 was small photo types and large photos. Okay, do we know the number of photos she's going to display for the small size? No, we don't know that, right? Nowhere does it say that. And the number of large photos, no, we don't know that. The cost of the small photo is $4. The cost for a large photo is 10. So we know that from the previous tables that we have used, we have to multiply them across to obtain the last one, the last column. So that's 4x and 10y. Okay, but I do have to insert one last column. I'm sorry, row, which will be the total, right? Okay, because what happens is we have, at least 25 photos. Let me highlight that. You see that language, at least 20 photos? That at least means there's an inequality. So in the table, you don't see the inequality, right? But when you build the inequalities, you have to insert the inequality there. And also, it says she doesn't want to spend more than $200. More than, that's another phrase for an inequality. Okay. Anyways, I'm going to enter these details first, and then we'll look at the inequality. So she wants at least 25 photos to be displayed. She doesn't want to spend more than total of $200. Okay. Okay. From this, we'll build our inequality. So I have x plus y. She wants the small photos plus the large photos. Let's go back to the problem. To be at least 25. At least means a minimum of 25, right? 25 or more, that's what it means. So what symbol would you use? Yes, we'll use greater than or equal to, right? You know it has to be equal to because it did not, when it says at least indicates that a minimum of 25. So 25 or more is what it means. And for that, we use the greater than or equal to symbol. Okay, that's from the first one. The last column is 4x plus 10y. This is the cost, right? The total cost for the small photos plus the total cost for the large photos must be, go back to the table, to the problem. It says she doesn't want to spend more than 200. So in fact, I have to highlight that. Doesn't want more than. Otherwise, it sounds like more than. And she doesn't want to spend more than 200. That means she wants to stay under $200. To stay under $200, it says no more than. Okay, so you can go up to 200. That's what it means, but no more than that. Therefore, I will use less than or equal to 200. Okay. Doesn't want to spend more than means no more than. No more than means you can go up to 200, but not more than that. Therefore, the equals bar for the less than equal to. Let me write that clearly. All right. So we built two inequalities. Okay. Now, these are inequalities. So you really can't graph them. You really can't solve them using substitution method or elimination method, right? You have to graph them. This goes back to what we did in chapter 4 towards the end of it, okay? So we did graph them, and then we tried to locate a test point, and then we tested it to see if we should shade that region or shade the opposite region. That's what we're going to do, just that we're going to do it twice for two inequalities. Okay. So we are going to now go ahead and graph the first one. These are linear inequalities, so we're going to graph them as lines, and remember to use shade or dashed lines as the boundary line. Both have the equals bar in it, so both will have to be solid lines. So I have two tables here for each of the inequalities. Let's take the first one. I want to use the intercept method. So when x is 0, I get the y-intercept. When y is 0, I get the x-intercept. So let's do that. So when x is 0, y is 25. I'm looking at the first inequality, right? First one. Maybe I'll call them 1 and 2 so that you know that this is related to 1 and this one is related to 2. Okay. All right. When y is 0, x is also 25. Okay. So I got the coordinates for the first one. Okay. I have to go there and plot them, but we got it there. And then I'll use a different color for the second one. I'll use green. Once again, I have a 0 for the x and a 0 for the y. I'm skipping the calculation. You can pause the video and do the calculation yourself. So when x takes, when you plug in x as 0 here, right? I'm just going to walk you through this. You get 10y equals 200. Remember, we used to assume it as if it was an equation. So don't worry about the inequality yet. We're just trying to find the y value. So then divide both sides by 10, you get y equals 20. So when x is 0, y is 20. Then plug in y as 0. So plug in y as 0 here. That means this term goes away. 4 times x equals 200. Divide both sides by 4. So x equals 200 divided by 4, which is 50. Okay. We got these 2 points for the second one, and we need to go ahead and graph it. If you look at our table, pretty large numbers, right? 25 and 50. So if you look at my grid, it already has these numbers there. But you can see that obviously these numbers are not going to work, right? We need them to be really large. So if I jumped by 5s, if my scale was 5 unit each, then I could have a way to accommodate these large numbers, right? So I'm going to change these ones. So that's going to be 5, 10, 15, 20, 25, 30. Yeah? 5, 10, 15, 20, 25, 30. Again, this will be negative 5, negative 10, negative 15, negative 20, negative 25, and negative 30. What about the y-axis? Well, I come back here. Yes, the y-axis, the y values are also 25 and 20s. So we really need to do this. But hey, I'm looking at the scale and I don't see room for 50. So I'm going to change my scale here to be 10, 20, 30, 40, 50, 60. Okay, and I'm going to change this. Negative 20, negative 30, negative 40, negative 15, negative 60. However, my y's are in the 20s, so perhaps I could continue to do this as 5, 10, 15, 20, 25, 30, 35, 40. Okay. Good that we're doing this, because what you notice here is your x-axis has a different scale and your y-axis has a different scale, which is perfectly fine. The only thing is you cannot have different scales for the x on the right side and the left side, or different scales for the y on the upper side and the lower side. That's all we need to care. But we can have different scales for the x and the y's. Okay. So the scale on the x, let me write here, x-axis is 10 units each. And for the y-axis, it is 5 units each. I want you to understand that, okay? If you are doing on your graph sheet and you are jumping by 5s both ways, okay, we are doing the same graphing, but the graph slant would look different because my scale is different than yours. Okay, now we also established that both of them, both these inequalities will have a solid line. So 0, 25. Let me mark that. That's my first inequality. 0 and 25. Well, I have to mark it here, right? 0, 25. And the other one was 25, 0. That one has to be here. So 25, 0. Let me just write it somewhere there. 0, 25. And this is 25, 0. I need to draw a line through these 2 points. Let's see how that comes out. Okay, that moves. This is kind of hard to. Okay, let's try that again. And that will be, what's the inequality then? X plus y greater than or equal to 25. Okay, but it is equal to 25 because it's first of all a line, right? But when we shade it, you can actually see that that's the inequality. So we come back. Let's not graph the other one yet because we need to find the shaded region for this one, right? So we need to use a test point. We use 0, 0 as our test point. So I'm going to come over here on the left. I'm going to use red for the 0, 0. I'll use it on the right. Okay. 0, 0 is our test point. X plus y greater than or equal to 25. Let's plug in a 0 for x, 0. So our statement comes out to be 0 is greater than or equal to 25. That's a false statement. So which side do you think we have to shade? 0, 0 is right here, right? On the left side of the line. So we need to shade on the right side of the line, okay? So I will just write a little note here. Shade right side. I'm not going to shade it yet because we have another inequality to graph. We need to find the common overlapping region for both these inequalities. So let's hold on to that information. And let's graph the other one. The other inequality is 0, 20 and 50, 0. I'm going to use green for this. 0, 20 and 50, 0. 50, 0 is right here. And we need to draw a line through these two. Okay, kind of close, it's not exact, but that's okay. And the inequality is 4x plus 10y less than or equal to 200. 4x plus 10y less than or equal to 200. Okay. Now imagine that there was no red, there's only a green, right? Now for the green, if the green was the only thing on the grid, then you still have the 0, 0 that's available. Right? So we can still use that as the test point. And that was 4x plus 10y less than or equal to 200. So that's going to be 4 times 0 plus 10 times 0 less than or equal to 200. 0 less than or equal to 200. Is that a true statement? Yes, it's a true statement. So in terms of green, would you shade the region above green or below green? Well, the test point came out to be true, right? So you're going to shade the region that has the test point. In this case, it's going to be below the green. Okay, shade below. Okay, so now I want you to see that the overlapping region for these two, right, would be for the red, it's the right side, right? And for the green, it's the bottom. So between red and green, what is the common overlapping region? You see that the right of red and the below of green actually coincide in this particular spot. With me on this? And that is the solution for these two. So if you go back to the question, it had 4 parts, okay? And we just did the graphing part, okay? Because that's the only way we could even talk about the solution. You could test if a point is a solution or not, but to see the entire solution region, we have to do the graphing. Let's go back to the question here, see if we have answered them. Now, did we write a system of inequalities to model this inequality? Yes, that's here, okay? So this was our part A. We answered part A there. Graph the system. Did we graph it? Yes, we just did that. So this is part B that we just answered, okay? For part C, let's see what it says. It says, could she display 15 small and 5 large photos? Okay, 15 small and 5 large. So your X is small and Y is large, right? Okay, so come back here, and in your grid, in your graph, I am going to write the X, okay, as small, because that's what we agreed X to be. And the Y was large, right? Okay. And for the sake of clarity, I'm going to erase the test point. If you ever want to see this, you can always rewind the video to come to the point where we did this test point. So this will be erased now. For part C, the question says, let me go back to the question. Could she display 15 small and 5 large photos? Okay, 15 small, put it up here, and 5 large, okay? Small is your X, right? Yeah. So this is a graph. So if I were to do X comma Y, it is the same as small comma large, agreed? So our coordinate will be 15 comma 5. So if you can find this point in the shaded region, then it is a solution, right? That means she can display. If it is not in the shaded region, then she cannot display. Okay, that means the constraints of her budget and the constraints of how many she wants to place, the number of small and the number of large, all those constraints are contained in the yellow shaded region. If anything lies outside the yellow shaded region, those constraints are not considered then, right? But we did all this because we wanted to give her the optimal solution to her situation. So here we go. 15 comma 5. Let's locate 15 comma 5 in our grid. Okay. 15 is midway, right here, between 10 and 20, and 5 is here. So let me mark that and call it 15 comma 5. Is that in the shaded region? No, unfortunately it is not. Okay. So I'll say 15 comma 5 is not a point in the yellow shaded region. The shaded region is our solution, right? This implies 15 comma 5 is not a solution to the system. This implies She cannot. Now we have to go back and interpret the question, right? So which means she cannot display 15 small and 5 large photos. Okay, so we answered part C. We need to go ahead and look at part D. Again, this section will be erased. Part C answer that we just did will be erased. And section D, part D would be responded here. And if you have to look at this again, you can always rewind and look at the video at that point. Okay, we're looking at part D. Could she display 3 large and 22 small photos? So let's come down here. Okay, so we need to see if she could display 3 large and 22 small photos. 3 large and 22 small photos. Okay. X comma Y is small comma large. You really have to understand that the ordered pair is ordered the same way always, right? Your X represents small, Y represents large. So remember that the question actually has twisted it around. It said 3 large and 22 small. So try to put it as 22 comma 3. Okay. 22 comma 3. And that will tell you it's 22 small and 3 large. Okay. We're going to go look for this point on the graph. 22 and 3. Do you think that's lying in there? 22 and 3. Okay. That's a little tricky there, right? So it's kind of hard for us to determine that. Okay, now because I cannot actually see, because you have to eyeball those values, right? 22 is somewhere here and 3 is somewhere there. It appears as if it is maybe on the borderline, right? When we have those kind of difficulties, we can always fall back on the reliable algebra, okay? What does algebra tell us? Algebra tells us that we could plug in these values in our inequality to verify if it's a solution. Remember the verify? So I come back here and I say, okay, I have the first inequality is x plus, let's write it out here, x plus y greater than or equal to 25. Divide the page here. And the other one was 4x plus 10y less than or equal to 200. Let's plug this in. Okay, x is 22 plus 3 greater than or equal to 25. 22 plus 3 is 25 greater than or equal to 25. Is this a true statement? Yes, the greater than part alone is not true, but you have the equals bar, so 25 equals 25. That part makes it true. That's a true statement. Let's come here. So 4 times 22 plus 10 times 3 less than or equal to 200. That will be 88 plus 30 less than or equal to 200. 118 less than or equal to 200. Is that true? Indeed, it's true. Both came out to be true, which means 22,3 is a point in the yellow shaded region, but it is so close that you really can't tell, at least from the graph. But when you did it algebraically, it gave you a clear-cut answer, no ambiguity there, and it tells you that yes, she can display 22 small and 3 large photos. Okay. Now the red and the green lines you see in the shaded region, are they included in the answer or not? They are included in the answer because actually this point technically is in the borderline, so it's very close to the border. But remember that the border is included because it's a solid line. If it was a dashed line, any answer that falls right on the line would have been excluded from the solution. But here they are included in the solution. So I come back here and I conclude, yes, she can display 22 small and 3 large photos. Okay. Just for, you know, just for us to understand, I'll just throw in one more. Say there was a section E, a part E in this question. Okay. What about 30 small photos and 5 large photos? Do you think that's a solution? 30 small and 5 large. Okay, so you come back here, 30, 5 is right here. It is right in the shaded region. So you know, yes, she can display 30 small and 5 large photos, right? So as long as it falls within the shaded region, it's totally fine. Okay. The only catch here is it is a word problem. So please understand that the negative quantities are really are not of much help, right? Here. So you want to talk about the positive part only. So the positive part of the solution is the only one that will work in a word problem. If it was a regular problem, then the whole shaded region will work. But here it's only the top triangular part up to the x-axis that will make sense in our given problem. Okay. I hope you enjoyed the application of linear inequalities. I will see you in the next video where we move to the next chapter. Thank you then. See you soon.